Hi there. We are now looking at sampling and estimation, and particularly we are going to be looking into confidence interval, where the population is normal and the variance is known, and the sample could be a small or very large sample. It doesn't really matter. So immediately we're going to be looking at an example and try to work through this and see how we can find a confidence interval. Now here is the example. The lifetime of batteries manufactured by a company has a normal distribution with variance 225 hours. A random sample of 10 batteries is selected and their lifetime was measured. were measured. The sample mean lifetime was found to be 100 hours. Now we need to construct a 90% confidence interval, and for the second part, a 95% confidence interval for the mean lifetime of the batteries. We also need to find the width of the confidence interval in each case. Okay, for this particular question, we are told that it's a normal distribution and the variance is 225 hours. Also, it's a normal distribution. Now, the random sample is n is equal to 10. 10 batteries are chosen. The sample mean, that is x bar, which is basically the sample mean, that has been given as 1550, 100 hours. So if we want to find a 90% confidence interval, 90% confidence interval, first of all, I would like to find the z value for this confidence interval. So basically what I do, I just draw a normal distribution curve and I look for the area where I can approximately say that this is basically 90%. So if this is 90%, I'm going to take then 1 minus 90 over 100, and that comes to 1 over 10, and then divide by 2 because we've got two areas. So 1 over 10 divided by 2, and that's going to give me 0.05. So this area here is 0.05, and this area here 0.05. Now that's my negative one and that's my positive value of z. So from here what we can do, which is the phi of z is going to be equal to 0.05, and of course because this is to the right, I can say 1 minus phi of z, get the area to the left, and so z is going to be equal to the phi inverse of 1 minus 0.05. So phi inverse of 1 minus 0.05 is basically 0.95. And if you were to verify or check this out from your statistics table, you will see that it gives you 1.645. So 90% confidence interval. Now I can calculate my confidence interval by using the formula which would be in your book. So x bar plus or minus z times the standard deviation over the square root of n. So the sample mean has been given as 1550. I've got a plus or minus my z value, which is 1.65, which I just calculated, times the standard deviation, and of course the standard deviation is the square root of 225, which is 15, divided by the square root of the sample size, 10, and this leads me to 1550 plus or minus, we're going to calculate this now, calculator here, so I got 15 divided by the square root of 10, and then multiply by 1.645, and I get 7.803. Okay, 7.803. Basically, I can now calculate my upper limit. So the upper limit is going to be 1550 plus 7.803, and all of that's going to come to 1557.8, and the lower limit is going to be equal to 1550 minus 7.803, and that comes to 1542.2. So a 90% confidence interval for the mean lifetime. So the mean lifetime is then 1542.2. That's the lower limit, going to the upper limit 1557.8. Now if I want to find the width, so basically the width is this. So what I do then, I take the upper limit minus the lower limit. So upper minus lower is going to be equal to 1557.8 minus 1542.2. So my limit, my length, or the width, okay, I would say the width of this is going to be then equal to 15.6 hours. So basically this is the width of confidence interval, the width of confidence interval. I'm sure you get that. Now the second part of the question, let's take a look how we can do this. So nothing difficult there. Then for the second part, we want a 95% confidence interval. So basically, this time the Z value, if you were to calculate this, again, you're going to draw your normal distribution curve. So 95% will be somewhere here. So what you do, you take away 95%, and then you divide by 2. And you get 0.0. So 0.025. So 1 minus the phi of Z is equal to 0.025. So phi of Z is equal to 1 minus 0.025. So 1 minus 0.025, and this is Z now is equal to phi inverse of 0.975. Check this out from your statistics table. You should be able to see that it is 1.96. So the 95% confidence interval, we have the sample mean. The sample is basically now, the sample is the same as given, all right, and then standard deviation, we know is 15, and you got your sample size, which is 10. So again, we're going to be using X confidence interval, X bar plus or minus Z into standard deviation of the square root of n. So now I have then X, which is 1550 plus or minus, this time 1.96. Standard deviation is 15 over the square root of 10. And of course, you're going to be working this out with the calculator, and should be able to get 1.96 times 15 over root of 10. And that gives us 9.29. Okay, so 9.29, let's say 9.297. All right, and so 1550 plus or minus 9.297, so on. So my upper limit is going to be 1559.297, which is 0.3. And the lower limit, you just take this and you add it here. So lower limit is going to be equal to 150 minus this, 1550 minus what we have here is 1540.7. So I can confidently say now that a 95% confidence interval, so hence a 95% confidence interval for the mean lifetime is as follows. We got lower limit 1540.7, comma 1559.3. So here we are for that second part, and now with the width of the confidence interval, width of confidence interval, and that's going to be 1559.3 minus 1540.7 comes to 18.6. All right, so take care.